Welcome to my channel. What if I told you that one of the world's most luxurious fabrics is made by a tiny worm? Yes, it is silkworm who produce high-quality silk. Watch how silkworms transform simple mulberry leaves into beautiful silk through an incredible natural process. Watch this video till end without skipping any part in order to updated information about silkworm and sericulture. This video is going to be very interesting and helpful not only for students but also for those who want to adopt sericulture as business. So, it is more important for you to subscribe this channel to get new videos on time. So, press the bell icon below this video. Also comment and like. And share this video with your fellows. The term sericulture is used for cultivation of silkworms in order to produce silk commercially. This includes the breeding and management of silkworms for commercial production of silk. Sericulture is an important industry in Japan, China, India, Italy, France and Spain. Bombyx Mori is the only living species of superfamily Bombycoidae and has been domesticated for so long that it is possible that there are no survivors in the wild any longer. Discovery of silk production from bee, Mori occurred about 2700 BC. Silk production started from China by Emperor Huangtai. Silk industry began in China where the source of silk was kept a secret for more than 2000 years. After some time, China lost their monopoly in silk production. Sericulture reached Japan through Korea and then to other countries. Except Bombyx Mori, some other species have also been in use to produce silk. These species include Antheria mylitta, Attacus ricini, Antheria asma, Antheria pernei, Antheria yamai, Philosamia cynthia, Antheria royali and Attacus altas. The Tarsus silkworm was known as Antheria mylitta, Eri silkworm was known as Attacus ricini, Munga silkworm was known as Antheria asma, oak silkworm was known as Antheria pernei, Japanese oak silkworm was known as Antheria yamai, wild silkworm was known as Philosamia cynthia, Himalayan silkworm was known as Antheria royali and giant silkworm known as Attacus altas. Bombyx Mori is mainly cultivated into Kashmir, Tamil Nadu, West Bengal and Punjab. Depending upon the climatic condition, the silkworm are classified into univoltine and bivoltine. Univoltine species are those which have one generation of crop per year. This species is known to produce good quality of silk. It is cultivated in Jammu Kashmir. Other species is bivoltine which have 2 generations per year. This species is known to produce inferior quality of silk and is cultivated in Bengal, Assam and South India. This picture shows the structure of male and female Bombyx Mori specimens. Let's study the life cycle of Bombyx Mori. First stage of the life cycle is egg. An egg is the first stage of the life cycle of the silkworm. The egg is laid by a female moth which is mostly the size of small dots. A female moth lays more than 350 eggs at a time. In the springtime, the eggs hatch due to the warmth in the air. This procedure happens once in every year. Second life stage is known as silkworm larvae. A hairy silkworm arises after the eggs crack. In this stage of silkworms, the growth happens. They feed on mulberry leaves and consume a large amount of these leaves for around 30 days before going to the next stage. The next life stage is cocoon formation. In this stage, silkworms spin a protective cocoon around itself. It is the size of a small cotton ball and is made of a single thread of silk. Next to cocoon, pupa form occurs. The pupa stage is a motionless stage. In this stage, people kill the pupa by plunging the cocoon into boiling water and unwind the silk thread. When mature, this pupa changes into an adult moth. The female moth lays eggs after mating and thus the life cycle of silkworm begins again. This picture shows the detailed life cycle of silkworm. Adult insect lay eggs on the mulberry leaves. Larvae emerge from these eggs and start feeding on the mulberry leaves. The other mature silk cocoons which undergoes a sequential process to obtain good quality silk. Processing of silk is actually the process of extraction of silk from cocoon. It consists of a number of steps which are as follows. First step of silk process is separation of silk from the cocoon. This is done by exposing the cocoon to sunlight. Next step is reeling of silk. The process of unwinding silk from a cocoon takes place. Next to reeling is bleaching of silk thread, during which decolorization is done. Then spinning of silk fiber into silk thread occurs. The silk fiber is then spun into silk threads. Let's discuss what types of tools and materials are required for the production of silkworm and silk. So first tool to know is machana. Machana is the proper place for rearing the silkworm. Rearing tray is used for keeping the laid eggs along the mulberry leaves. Next is spinning tray. It is used for keeping the caterpillars at the time of fully grown stage ready for pupation. Dalas is used for fetching the mulberry leaves into smaller pieces. Moreover, baskets, hygrometer, thermometer, oven and freezer are also used in this process. Next is grainage management. For this purpose, a place is required for commercial production of silkworm seed eggs. Grainage management process include the selection of cocoon, segregation of sexes, egg production, incubation and hatching of eggs, rearing of larvae, production of cocoon, stifling, reeling and spinning. Following are the important points to be focused during selection of cocoon. Large and healthy cocoons must be selected. Healthy brooder specimens must be placed in well-ventilated room at temperature 25 degrees centigrade, humidity 75%. These brooder cocoons must be arranged in single layer in each tray. Multiple trays can be managed at the same time for mass production. Cocoons of different sexes are separated. Separation must be done before emergence of pupa to avoid self-breeding. After 15th day of cocoon formation, male and female adults emerge from these cocoons. Then they mate, which completed after 6 hours. Males will be separated and stored at 7 to 10 degrees centigrade. Eggs are produced by using different methods, viz. cellular bag method, cellular card method and flat card method. Ripe healthy cocoons are used for eggs production. Moths emerge from these cocoons, lay eggs in a cloth bag and die. Then removed from the bags. Eggs are checked for infections and healthy ones are kept for incubation. Incubation period prolongs from 8 to 12 days. Incubation will be done at 4 degrees centigrade temperature. The process of incubation can be done either on sterilized trays or on mulberry leaves. To adopt second option, availability of mulberry leaves is must, otherwise the eggs will be placed in diapause condition. Hatched caterpillars are 5 to 7 mm long with rough, wrinkled grayish color body. Body has 12 segments including head, thorax and abdomen. Head had mandibulated mouth parts. Thorax has 3 segments, each with a pair of true legs. Abdomen has 10 segments and third, fourth, fifth, sixth and 10th segments have pseudolegs. Spiracles are present on lateral sides of abdomen. Caterpillars are placed on chopped mulberry leaves as shown in this picture. Rearing temperature is adjusted at 27 degrees Fahrenheit and between humidity range of 60 and 70%. The larvae feed voraciously on mulberry leaves and grow fastly. Larvae undergo 4 moltings. Maturity reached in about 45 days after hatching. Mature caterpillar 7 to 10 cm long and has salivary glands. Caterpillar stop feeding and start lifting and moving its front part in circular fashion. Transferred to spinning tray, dry leaves, twigs, straw. Caterpillar release sticky secretions from silk gland. This secretion come in contact with air and transferred to fine silk thread. Thread wrapped around the body of larvae to form cocoon. Pupation over within 15 days. During pupation, metamorphic changes occur and abdominal prolegs lost, wings appear on the thorax. Cocoons are collected and preserved. Pupa change to adult moth, imago, in 15 days. Imago release alkaline fluid to soften one end of cocoon and escape, mate, lay eggs and die. Next is the process of stifling. Process of killing the pupa inside the cocoon to avoid cutting of silk thread. Cocoon kept over porous tray placed over cauldron containing boiling water. Steam kill the pupa inside the cocoon and loosen the silk thread. Steamed cocoons are kept in dry place to dry up the dead pupa. After stifling, reeling will be done. Process of removing silk thread from killed cocoon is called reeling. Killed cocoons are dipped in water in metallic vessel for 15 minutes and stirred. Silk thread from 4 to 5 cocoons are twisted together and wound on reel or spool by reeler machine. Doubling and twisting. To create thicker, stronger yarn, threads from 2 or more bobbins are combined, doubling, and then spun, twisting, to give them strength and elasticity. Heat setting. The twisted silk is steamed so the twist sets permanently into the thread, preventing it from curling or unraveling. Rewinding. The final thrown silk thread is rewound onto smaller bobbins, cones, or spools, which are then placed directly into looms for weaving. Doubling and twisting. To create thicker, stronger yarn, threads from 2 or more bobbins are combined, doubling, and then spun, twisting, to give them strength and elasticity. Heat setting. The twisted silk is steamed so the twist sets permanently into the thread, preventing it from curling or unraveling. Rewinding. The final thrown silk thread is rewound onto smaller bobbins, cones, or spools, which are then placed directly into looms for weaving. Thanks for watching. Like and share this video. Subscribe this channel to get more informative videos and to become part of a growing scientific community.